Okay, we have an improper integral of type 1 because we're going to the left forever. So to evaluate this, we can rewrite it as a limit. And t is going to be approaching negative infinity on my integral from t to 0, x e to the x dx. Problem is taking the antiderivative of x e to the x. So to accomplish this, we're going to do integration by parts. And I'm going to let u, u, u equals x, which means the rest of it is going to equal dv. So dv equals e to the x dx. So take the derivative, I get du equals dx. Take the antiderivative, I get v equals e to the x. I'm going to utilize that to do my integration by parts. So then when I take this, I'm going to have what? U times v. U times v. And I'm going to from t to 0 minus, it's going to be v du. So v du, which was dx, again from t to 0. So I still need to take the, and of course we're going to take the limit of all of that. So this is just inside of there. And then that's going to give me, so I shouldn't put an equal sign there. What this really is this. Okay, so I'm going to simplify this further, and I get what? E to the 0, 0 times e to the 0 minus t e to the t minus, going to take the antiderivative of e to the x, which is e to the x from t to 0. Of course, this is a 0, so I got negative t e to the t. Going to plug in 0 here, so when I plug in e to the 0, I get 1. And then a double negative is going to be plus e to the t. So I'm just going to bring this down here for a second, and I'm going to now take the limit as t approaches negative infinity of this, because that's what I was calculating, and that is negative t e to the t minus 1 times, plus e to the t. So what does that equal? Let me move that over here, working down. Okay, the first part, I cannot take the limit directly, so I'm going to write that as a limit. Limit as t approaches negative infinity of negative t e to the t. However, I can take the limit of this. It's just going to be minus 1. So that is everything in my limit. Let me move this up a little higher. Minus 1. And the limit of e to the t as t goes to negative infinity is going to be 0. So right now, to answer this question, I just have to evaluate this last limit. Now, what I'm going to do is play with this for just a little second, and I'm going to rewrite this limit. So I'm just working with the limit right now. I'm going to do this over to the side, and I am talking about the limit as t approaches negative infinity of negative t e to the t. One thing you might want to notice is I can rewrite this as a fraction, which is a tool that we have used before when evaluating limits. Oops, not an equal. Bracket. Got a negative t divided by e to the negative t. Says the exact same thing, just put this from the top to the bottom. You change the sign of the exponent. But what you should notice is on the top, as t goes to negative infinity, the limit of the numerator is negative infinity. And if I look at the denominator, e to the negative t, so I got a negative, and I'm going to negative infinity, so double negative is positive infinity. So this is going to give me basically infinity divided by infinity. That means we can use L'Hopital's rule. So I shall, and I will take the derivative of the top, and I will take the derivative of the bottom. So when I take the derivative of the top, I get negative 1. When I take the derivative of the bottom, I get negative e to the negative t. Of course, these negatives on top and bottom give me a net positive. Now, let's talk about this limit here. I'm going to simply rewrite this. And that's a negative infinity on the limit, sorry, as t goes to negative infinity. So as t goes to, actually, I don't think I have to rewrite that. Never mind. Yes. No, I don't. Sorry. Right here. Well, no, we will. Never mind. I will rewrite it. I'm going to rewrite this. Doesn't really matter. As e to the t. Okay, e to the t is an exponential growth function. As I go to the left, negative infinity, I'm going to 0. I know this limit. Let's put this limit as 0 over here. Okay, that's what I needed. Right there, that is 0. So my final answer is 0 minus 1 plus 0, or negative 1. So I was able to evaluate this, and I ended up with negative 1, which means I have convergence. So that's it.